So good morning, good afternoon and good evening everyone. So welcome back to today's class, and we were studying about atomic structure, and we have seen regarding discovery of subatomic particles, and we have also studied about different models of your atomic model, that is your J.J. Thomson Rutherford, and the third model, that is your Bohr's atomic model. So before studying this Bohr's atomic model, we have also studied regarding developments that led to Bohr's atomic model. So what are these developments? They are your different wave nature, particle nature, and different phenomena related to these things. So we have studied all of that, and then now let's go into Bohr's atomic model. This model is given by Bohr himself. So the name is been given after the scientist name. So what are the first postulates we have to understand when we are studying about Bohr's atomic model? It indicates that like how the electrons are being given, how electrons are distributed around your nucleus, and how they are revolving around the nucleus. All that we will be observing here. We have given that, suppose according to Rutherford, if this is the nucleus which is present between, the electrons will be revolving around the nucleus in a circular orbit. So Bohr has told that yes, the nucleus will be present in between your atom and electrons will be revolving in a circular motion. So that is called to be your orbit. So here if you take electrons revolve around the nucleus in a definite velocities. Definite velocities means with a particular velocity they will be revolving in certain path. So that circular path, that certain path which has a fixed radius, and which has a fixed energy, and when any electron with a certain particular path we are studying, that has a particular velocity as well, right? So we will be talking about the radius of that circular path where the electron is revolving. We will talk about the energy of that electron where it is revolving, and also with regarding your velocity, right? And these circular paths are called to be your orbits, or we will also call it as principal energy level. We will also call it as your principal energy level, main energy level, or shell or shells, main shells or shells, right? So how are they arranged? They are arranged in your concentrically around the nucleus. So they will be arranged in your concentrically around the nucleus. Not only your one orbit, we will be having n number of orbits where electrons will be present. So if this is your nucleus, okay, let's draw. Here if you take, this is the nucleus that we are having, this is the first orbit that is there, right? I hope if I am here, let it be easy. If this is a nucleus, this is the first orbit that we are having. The second nucleus, it is revolving, third orbit, fourth orbit, fifth orbit. So like that it keep on continuing going with that. So for this shells or main shell or energy shell, Bohr has given a name for it. What are those names? So we will be starting with the number. He told that this is red color one is your first one, yellow is second. There won't be having any colors to differentiate that, it is been given on the PPT. But it will be having as 1, 2, 3, 4, 5, 6, 7, 8, and it keep on going. It continues. You will be able to have till infinity. If an electron is reaching infinity, that means that electron has been removed from your atom, right? Now, not only one, in alphabetical manner if they have to give the name, so it will be starting from K, L, M, N, O, P, Q, R, S, and it continues, right? So like there is no such thing why he has given a name starting from K, we don't know that, so don't get that doubt and all. So even after if you are reaching till Z, fine. After if you have reached till Z, come back again to your A. So right, so that's how the naming will be going on, and there is no such an atom where the electron has reached to an orbit maybe R or S. So in future if anyone is from you, if anyone is finding out, you are most welcome, right? So how the atom will be present? So in that case, if this is your nucleus, so this is your first orbit, second orbit, third orbit, fourth, fifth, sixth, keep on you can go. So this will be your n is equal to 1, where here the n is indicating your principal shell number. So which is the main shell, that number is given by n. This will be equal to 2, this is equal to 3, this is equal to 4, 5, 6, 7, 8. You can continue. Right, so this is where the electrons will be revolving around your nucleus in an orbit. Now the second, like this is how the electrons are arranged, and there was a drawback in your Rutherford that when a charged particles are revolving, they should be falling into each other, right? So, well, that is not happening. According to atom, it is being stable. Why it is not happening? Because if we take electrons, when they are revolving in certain path, in a certain circular path with fixed velocity, energy and radius, they won't be either gaining energy, they will neither lose energy. So they will just, with a stationary phase, they will be just revolving in a circular path. So wherever the electron is present, it will be present in that particular path only. They will be just revolving, they will neither gain the energy, they will neither lose the energy. This is the second postulate. We'll study about that as well. Third postulate, suppose if electron has gained the energy, at the time what is going to happen? If electron has gained the energy, at the time the electron from your lower energy state, it will be reaching towards higher energy state. So from lower energy state to it will go to higher energy state.